This is the homework video that goes with Progress Check 2 with the logs. So first, property of logs. You have to expand each of them. So there's 4 different ones. The first one is product, and that's when you have log and you multiply 2 variables. You can then take the log of the first variable plus the log of the second. Second one is log of a quotient. It's when you're dividing within a log. You take log of the first variable or the numerator minus log of the second variable or the denominator. Third one, and the most common one we see while we're solving log equations, is log of any power. That's when you have some variable to another variable, you move that power in front and you multiply that number that the power is by log of the base number. And then lastly, log of any reciprocal. That's a special type of log of a quotient, and it only happens when 1 is in the numerator. When you have that, you have negative log of the variable that is the denominator. In this case, it would be s. So our first example is 9.3 to the 2x plus 1 equals 930. Solving by logs, solving by log properties, the first thing we do is log both sides. As we can see, we can now apply the property of log of a power, and we move that whole power to the front. Now, you do the whole thing, not just the 2x. 2x plus 1, everything goes in front. So we have 2x plus 1 times log of 9.3 equals log of 930. We can now divide by log of 9.3, and we have 2x plus 1 equals 3.065. Just like a simple equation, we solve for x, we first subtract 1, and we get 2x equals 2.065, and then we divide by 2. We get x equals 1.033. Now, to check to make sure our answer is right, we plug x back into the equation. So you do 9.3 to the 2 times 1.033, because that's what we found for x, and then add 1. The 2 times 1.033 plus 1 is all in the power. When you put that back in your calculator, you should get something very close to 930. Okay, so our second example. First thing we have to do is get that exponential base to itself. So we have to subtract 14. So we have 4x, or 4 times 7 to the power of x equals 72. Now we can divide by 4 to get that 7 to the x by itself. 7 to the x equals 18. We can log both sides. And when you see with the 7x, we have a log of a product. Use that property, move the x down. X times log of 7 equals log of 18. Divide by log of 7, and we get x equals 1.485. Sorry, that last number does not look like a 5. Then you would do what we did last time, plug x back in, so you do 7 to the 1.485, then multiply that by 4, and then add 14, and you should get something very close to 86. Okay, you have a concept problem. Now, on this problem, you can solve it either using the properties or by converting it to base 10. This says the amount of light that is able to pass through the water in a lake depends on the clarity of the water. Suppose that in one lake, the function rule for the light intensity measured in lux at depth of meters is the equation below. Use algebra and logs to determine the depth at which the light intensity will be 4,300. Now, some of you guys were confused with the bear problem. Where did that bear population go? It goes on and that one it was P of T. This case, it's I of D. So that's where you put your variable. So we have 4,000 equals 60,000 times 0.25 to the D. First step is to divide by 6,000, and we get 0.0717 equals point. Now, if you look, I put 0.025 to the D. It should be 0.25. But we're going to keep on going with 0.05. Sorry, I can't go back and change it now. So you log both sides. we then apply the product power, or product property, and move that d in front. Then we can divide by log of 0.025, and we get d equals 0.71. Now, it's important to go back, put that back into the equation and check, because I already stated we did not use the right number. 0.025 is not part of the equation. We needed 0.25. So if we put that back in, we would realize we did something wrong. But for this sake, I apologize. Can't go back and change it. With these concept problems, there's one extra, or context, we need to do the meaning of the solution. So the depth of the water will be 0.71 at 4,300 lux. Now, if you wanted to solve it by converting it to base 10, you would still need to divide by 60,000 first to get that exponent power to itself. Then you can change that exponent power to base 10, and the way you do that is you do 10 to the power of, then you would log that base number, so the power of log to the 0.25, and then d on the outside, and then you would go from there and keep on solving. Now, hopefully this helps. Please take the retake and good luck, and remember, if you're not using logs to solve these problems, you won't be getting the right answer.